Okay, Venn diagram. Venn diagram is a tool for mathematicians to help them visualize their thinking in the sets. Venn diagram always start with a rectangle, and then we have a symbol of universe. Usually, there are three common places you can find the symbol of universe. The first place you might find them is here, the universe. It's right in here, or you might sometimes find it here, or you might sometimes find it here. So don't get confused. Every book have different way of writing. For now, let's just use the one that over here. Let's erase the other two under this. Okay, now let us start with our universe. Our universe, let's say our universe is set of number from 1 until 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we have a set of number. Let's say A is set of, let's say, 2, 3, and 5. Now, how to make them in a Venn diagram? First, we always want to start with the set itself. We want to make a circle to contain the set of A. So we have set of A here, set of A, we write A over here, and then inside the set of A we have 2, 3, and 5. But what happened is outside the set of A is the universe. So once again, from the universe, 2, 3, and 5 is taken. Okay, so we just need to write the rest of the numbers which is not written over here. So we have the rest of the number is 1, 4, 6, 7, and it's a very ugly 7 and 8. But can we write the rest of the number inside of the circle of A? No, because if you write it, for example, 7 here, for example, write 7 over here, it will become part of set A, which is not. So we don't want to write 7 inside of the circle A because it will belong to A. So this is how to make Venn diagram. Next example, let's make it a little bit more complicated. Let's say we have the universe is the same 1 until 8, 1, 2, 3, 4, 5, 6, 7, and 8. But now we have two sets. Okay, let's say we have sets A is same 1, 3, 4, and 6, and then we have sets B is let's say 2, 3, 6, 8, 2, 3, 6, 8. Now, how can we draw this in a Venn diagram? Let's make the first, we always need to write the, draw the rectangle, and then we have to name it the universe. It means the universe is contained between the rectangle. Now, for these two things, because we have two sets over here, we want to start with the intersection. What is intersection? Intersection is the same value between A and B. Is there any same value? Let's see, we have 3 here. We have 6. So we have 3 and 6. Both of them are the same. So it means 3 is belong to A and 3 also belongs to B. 6 also belong to A and 6 belongs to A, and then 6 also belongs to B. How to write it down? How to make it in the Venn diagram? So we have this one is for A. Let's make it red, and then let's make it green for B. Okay, B. Now B, this area, the area between A and B, this area is called the intersection area. This is where we need to write 3 and 6. So we need to write 3 and 6. Why? Because 3 belongs to A, and then 3 also belongs to B. Same goes with 6. So 3 and 6 goes here. So what about the rest? 1 and 4. We should write it inside 1 and 4, inside the A. So from here we can see that A have 1, 3, 4 and 6. How about B? We have 3 and 6 is taken, the rest is 2 and 8. So 2 and 8. But how about the outside number? Outside number. Now, let's list down again. We take the 1. So the 1 is gone. We take the 2, 3, 2, 3, 4 also taken. 6 and 8. 6 and 8. So we have two numbers which is not written yet. We have to write it down outside them. 5 and 7. 5 and 7. Should we write it here? Can we write it over here? For sure, but make sure it is outside this two circle. Okay, next, another example. Another example. Let's say we have the same universe. Okay, let's say they have the same universe, 1 until 8. The universe is 1 until 8. 1, 2, 3, 4, 5, 6, 7, 8. And then let's say we have D. Sets D is 3, 4 and 6, and then sets E is, let's say, 1, 2 and 5. Now, how to draw it in a Venn diagram? Okay, that's too big. It's okay, we still have enough space. First, we have to make the rectangle. Okay, that's our rectangle. And then we have the universe. The universe. Now, let's analyze this. Do we have the same value between D and E? 3, no. 4, no. 6, no. None of them are the same. So it means we don't have intersection between the two. We don't have intersection. Let's say this is the D, and then we have another one, the E. Now, since there is no intersection between them, you can see, right? So the D we have 3, 4, 6, 3, 4 and 6, and then E we have 1, 2 and 5. Now, how about the other number in the universe? Once again, let's recheck together. We have 1, 2, 3, 4, 5, 6. We have 1, 2, 3, 4, 5, 6. The one that remaining, 7 and 8. It means 7 and 8 is outside. Remember, you can write anywhere 7 and 8, but please write it outside D and E. Okay. If you remember, we can say D and E are disjoint. As you can see, we cannot find any similar value between D and E. So they disjoint. They're not connected each other. Now, last example. let's say we have, let's write again, our universe is 1 2 3 4 5 6 7 8, and then let's say we have f is 2n5, f g h, and then h is, let's say 1 2 4 5. Now let's make the Venn diagram. We start with the rectangle. Okay, that's enough. And then we have the U. Now let's analyze. Do we have the same value between them, f and h? We have 2, 2, 5 and 5. It means all of the f is inside the h. We can say that f is the subset of h. We can write f is the subset of h. It means all the value of f can be found in h. So how to make it? A subset is quite unique. So we have make a circle inside of circle. So we have a small circle here. This is for f. And then we have a bigger circle. Bigger circle. Whoop. Look like a donut. It's okay, I like donut. And this is h. Now, the smaller circle inside here, we have 2 and 5. 2 and 5. Then the bigger one, because 2 and 5 is taken already from the h, we need to write 1 and 4. 1 and 4. But remember the universe, don't forget we have 1, 2, 5, 4 is taken. So 1, 2, 5, 4 is taken. So the remaining one is 3, 6, 7 and 8. Okay, that's it for the Venn diagram. Thank you.